Hi everyone, thank you so much for stopping by this channel. Today we will be doing some problems on Fourier transform. So let's start with the sixth question first. So that is equal to x of t equal to 1 divided by 2 pi into t square plus 1. We have to find out x of omega. So here we are going to use the duality property, that is x of t having Fourier transform x of omega. When it is interchanged, we will get x of t, we will get 2 pi into x of minus omega. The duality properties proof and all the other properties of proof and notes are given in my Instagram account and also in my Facebook page, and some of the basic signals Fourier transform, and some problems are also given in my both of these accounts, social media accounts. If you want, please have a look at it. So let's come back to the question. So x of t equal to 1 divided by 2 pi into t square plus 1. So whenever these kind of questions come, we should compare that with the non-Fourier transforms. So when we look at it, it is 1 divided by 2 pi into t square plus 1. So we have to compare with the Fourier transforms of the signals that we know. So I am just taking an example here which resembles this. Okay, so that is minus e raised to minus t. So that is our a here is actually we take e raised to minus at and its Fourier transform is 2a divided by a square plus omega square, right? So if a is equal to 1, that is equal to 2 divided by a square plus 1, sorry, omega square plus 1, right? Omega square plus 1. And now I am just going to use the duality property here. So our omega will be replaced by t, that is x of omega. Instead of omega, we are going to replace it by t, and instead of the input signal where t was there, we are going to replace it with minus omega. Okay, now let's see what will happen. So that is 2 divided by t square plus 1, okay, equal to 2 pi into this 2 pi, okay, 2 pi into e raised to minus omega modulus, which will be modulus of omega itself. Okay, we have to find out the Fourier transform of x of t equal to 1 divided by 2 pi into t square plus 1. So this t square plus 1 we got, okay. So we should make this into 1 by 2 pi into t square plus 1 and make the corresponding changes in the other side, so that we will get the answer. We will see this. So it is equal to 1 divided by t square plus 1. So this 2 will go this side, which will be pi into e raised to minus pi, okay. And now what is missing here? 1 by 2 pi, right? So 1 by 2 pi here and 1 by 2 pi here. So the answer is 1 by 2 pi into t square plus 1 have the Fourier transform 1 by 2 into e raised to minus pi. C as the answer. Okay, so this is how it is done. Now we'll see the next question, the Fourier transform of t into e raised to minus t. So in the previous question we saw what was the Fourier transform of e raised to minus t? It was 2 divided by 1 plus omega square, right? And now we have to find out the Fourier transform of t into e raised to minus t. Okay, so finding out the property, we are going to recall the property of a Fourier transform, that is x of t having Fourier transform x of omega. When t into x of t is taken, then it becomes j into d by d omega of x of omega. So what happens here is t into e raised to minus t will yield us j into d by d omega of this one. There is only one t here, right? When it is multiplied with the t, then it becomes d by d omega of 2 divided by 1 plus omega square. Okay, so e raised to minus t, which is equal to, we will just differentiate it. So it will be, right, which is equal to j into minus 4 omega divided by 1 plus omega square the whole square. Okay, that's it. So the next question, the Fourier transform of, let's do the next question. In the next question, it is given that x of t equal to 1 divided by, sorry, it is t divided by 1 plus t square the whole square. Here also we are going to use the duality property. From the previous questions, we know that integral, Fourier transform of t into e raised to minus t is minus j 4 omega divided by 1 plus omega square the whole square. Doesn't this resemble this? So we are just going to do the dual, that is x of t having Fourier transform x of omega is interchanged and it will look like this. So instead of omega we are going to write it as t, that is 1 plus t square the whole square, and it will be, instead of omega t, it will be 2 pi into minus omega e raised to minus omega. Okay, so actually we have to find out this much only, right? So the other things we will take it on the other side. We will get t divided by 1 plus t square the whole square equal to 2 pi divided by minus j into 4 minus omega e raised to minus omega. So it will be equal to, okay, I'll just take another paper. So it will be equal to t divided by 1 plus t square the whole square equal to 2 pi divided by j into 4, right? So omega into e raised to minus omega. So we can simplify it. Instead of omega I am going to write 2 pi f. Okay, that will be minus j pi square f e raised to minus omega. Okay, so this is answer.